This session is related to discussion of topic motion, graph, and force from Unit 1 IAL Physics. In the first question, which of the following statements describe the gravitational field strength on a body at a point? So, gravitational field strength or value of the G. So, we have the formula that weight is equals to mass multiplied by gravity. So, gravity will be equal to weight divided by mass. So weight is a force. So which of the statement describes the gravitational field strength or value of a G? So it is gravitational force or weight per unit mass. So B is the right answer. Is it clear? Next question. A ball of mass m is projected vertically upward. An air resistance F act on the ball at all times. Which of the following equation would apply for a ball as it is traveling upward? So as the ball is traveling upward, it is accelerating and it is decelerating basically because the speed will decrease. And whenever acceleration or deceleration is there, there should be a resultant force. So if ball is projected upward, the force of a friction is opposing the motion. So this is the force of the friction which is opposing the motion, and weight of the ball also acting downward, that's equal to mg. So both of the forces are opposing the motion. The ball is projected upward, and what will happen? It will decelerate. So according to formula for the force, that resultant force is equals to ma. So what is the resultant force? The forces which are acting on the ball, that is F is acting down and W is acting down. So resultant force will be F plus W is equals to ma. And W is equals to mg, so we can say F plus mg is equals to ma. So resultant force is equals to ma. That's why D is the right answer. As the both forces are acting in the same direction, that's why we add them. If one of the force was acting, like if two forces were there and they are acting in opposite direction, then to get the resultant we will subtract them. Is it clear? Moving on to the next question. Two objects P and Q are at the same position when time t is equals to 0. So two objects were there, P and Q, and they are at the same position when time is 0. Then the graph shows velocity varies with the time for each object. So basically what happened for object P, as the velocity is positive and negative, what does it mean? It moves away from the position, starting position, and then it returned back. And how we know exactly it returned back? Because the area under the graph is same, because that represents the distance traveled by the object. But for Q, its velocity is increasing and acceleration is decreasing. Eventually it reach a constant velocity, but it does not change the direction of the motion for 4 seconds. So which of the following statement describe the position of P and Q when time t is equals to 4 seconds? P and Q are both at initial position. They are not both at initial position. P is at initial position but Q is away from its initial position. P and Q are at the same distance from initial position. That's also wrong. P returned to the initial position where Q is far away from the initial position. P is further from the initial position than Q. That's wrong. Q is further from initial position than P. So D is the right answer. But Q is far away from the initial position, the starting point, as compared to that of P. Is it clear? In question 4, a ball is traveling horizontally at a speed of 7 meters per second. The ball hits the vertical wall and rebounds to its initial path at a speed of 5. So the ball is traveling and then it rebounds. It changes the direction. The ball has an acceleration of 300 meter per second square. So acceleration is given 300 meter per second square. So if we consider, because this one is 7 and this one is 5. So if we consider this as plus 7, then the final we consider as minus 5 because the direction changes. And what is the formula which relate acceleration, time and change in velocity? It's v minus u over t. So if we need the time, it will be v minus u divided by a. So v is the final speed, that's equal to minus 5. U is the initial speed, that is 7. So we'll put 7 divided by the acceleration of the ball. Now what about the acceleration of the ball? As you can see, the magnitude of the velocity, like it was plus 7, now it is minus 5. So on the number line you have plus 7 to minus 5. So the magnitude of the velocity is decreasing. So if it is decreasing, we call deceleration, and whenever it's a deceleration, what we substitute? We substitute a negative sign. So we'll not write as 300, we'll write as minus 300. So option A is the right answer. Is it clear, this question? Okay, moving on to the next question. A structure of a popcorn kernel contain water. When heated, it turns into steam. The kernel pops and moves upward. So popcorn kernel is shown and it pops and it moves upward. The scale they represent, this length is 1 centimeter. So they give you an idea. Using a ruler, what you will do? You will measure this length and you will get the scale. Example, when you place your ruler or a scale and you are getting example, it's 2 centimeter. So actually the figure size and the actual size, so figure size 2 centimeter is equivalent to actual size 1 centimeter. Now the question, the photograph above shows a popcorn kernel just before popping at the maximum height after pops. And the time between the two photographs is 83 milliseconds. So we know the time, that is 83 milliseconds, or we can also say that 83 into 10 power minus 3 second. What is the maximum height? after popping. So how we can work out the maximum height after popping? So we can simply use a scale factor. You can use equation as well. You can use a scale factor. So if you use a scale factor, like you will measure this distance and you will compare like a scale. This is 1 centimeter and you will measure this length like the figure size you will measure. Example, it is coming out say 2 centimeter. So the scale factor, that 1 centimeter of actual size is equals to 2 centimeter of the figure size. Then you will measure this height. Say it is coming out as 6.8 centimeter. So if this is coming out as 6.8 centimeter, then actually it will be x cross multiply. You will get x as 3.4 centimeter. This is one way of solving this question, like measuring the height. There's also another way, because we know the time, and whenever object is there initial, it will accelerate due to gravity. So we can use the equation of the motion. We can use s is equals to ut plus half at square, in which the u is 0. So s is equals to 1 by 2 gt square. So it will be 1 by 2, gravity is 9.8, then it will be 83 into 10 to the power minus 3. So we'll get the distance, the vertical height it will travel from this formula. So it will come out as 3.4. It will be in meter and we can convert into centimeter. It will be 0.03 meter. If we multiply by 100, it will be 3.4 centimeters. The next part, calculate the initial speed of the popcorn kernel. So how we can find the initial speed here? Because basically what we are doing, if we consider that it returned to this position as they mentioned here in the question, that the time between the two photographs is 83 milliseconds. So we have the time interval, initial velocity we consider 0 for falling object, and we can find that height. Or calculate the initial speed of the popcorn kernel. So how we can find the initial speed? So we know the formula, the potential. We can use the concept of energy. We can also use the equation of the motion. Like equation of motion is there, v is equals to u plus at. So if we consider the final velocity to be 0, we can find initial velocity, and we consider acceleration is due to gravity, but we'll substitute a is equals to minus 9.8 as it is against the gravity, and multiplied by time interval, which is 83 millisecond. So 83 into 10 to the power minus 3. So this will move other side. We'll get the value for u, the initial speed. That will come out as 0.81 meter per second. So initial speed is 0.81 meter per second. The next part, the average water content in a popcorn kernel is 14% of the total mass. The kernel is heated until it pops, the steam ejected downward, and the popcorn kernel move upward with the initial speed of 1.5 meter per second. Calculate the speed at which the steam is ejected, and the total mass of the unpopped kernel is 0.11 grams. So this is related mainly to the momentum, relating motion with momentum. So the formula for momentum, the momentum is a product of mass and velocity. And the change in the momentum here, because if the total momentum before collision is zero, the momentum as initially before popping, the initial momentum is zero. So when it pops, the water will move downward and the kernel will move upward. So final momentum should also be zero. So we can use the formula m1 u1 plus m2 u2 is equals to m1 b1 plus m2 v2. Initial momentum is zero because initially it was before popping it is at rest, and when once it popped due to heat, water moved downward, kernel move upward. So this whole factor is zero. So initial momentum is zero. So m1 v1 plus m2 v2 is equals to zero. What is the m1? We can take the mass of the kernel as m1 and mass of the water we can take as m2. But how we can find the mass of this water? As I mentioned in the question, that the average water content is 14% of the total mass, and the total mass is 0.11 grams. So we'll find 14% of this, that will be the mass of the water, or the steam we can also say, and the remaining mass will be there for the kernel. So 14% of 0.11 gram. So this will be, so 14 that will be the mass of the water content, or H2O, or steam we can say. So 0.11 multiplied by 14 divided by 100, that will be 0.0154 grams. That will be the mass of water. And what about the mass of the kernel? That will, if 14% is the mass of the water, then remaining 86% will be there, the mass of the kernel. So, or this mass what we get, we subtract from 0.11, that will be the mass of the kernel. This will come out as 0.0946 grams. We can convert into kilogram, that does not make difference to the final answer, as we have to divide them. So the final momentum, if the initial momentum is zero, the final momentum should also be zero. So initial mass of the mass of the kernel 0.0946 multiplied by 1.5, that is the speed at which it moves, plus the mass of the water 0.0154 multiplied by the speed we don't know v2. So this 0.0946 divided by 1.5, sorry, multiplied by 1.5 and then divided by 0.0154, that is equals to 9.2. So the speed, because this will be 0.0946 into 1.5 divided by 0.0154, that will be v2, and it will come out as 9.2 meter per second. Is it clear, this question? How we worked out the speed at which this kernel, unpopped kernel, when initially it's unpopped, then when it pops, or the speed at which the steam is released from this kernel. In question 6, a A box was placed on top of the ramp and is released. The free body force diagram for the box as it moved down on the ramp at a constant velocity is shown. So the box is there on the ramp. Weight of the box is acting downward. The normal contact force is acting upward. And they mention it moved down the slope. So if it is moving down, this is the direction of the motion with a constant speed. So friction is a force which try to oppose its motion. The friction is acting upward. And air resistance, the force of the air is also there, that is acting. So which two forces acting on the box have, according to Newton's third law, corresponding forces on the ramp? So the corresponding forces on the ramp, first thing, this weight will have the component as we resolve this weight into its component. So here it is making an angle theta. So the component which is with an angle, that is W cos theta, and against the angle, that is W sin theta. So W sin theta, the weight is the force, the gravitational pull, and there is W cos theta which is acting on the ramp. So the normal contact force, that is the Newton pair force, so R is there, and W sin theta which is responsible for dragging this object or moving this object downward, that matches with the friction force acting upward. So B is the right answer for this, because we want the forces, which two forces acting on the box have a, according to Newton's third law, corresponding forces acting on the ramp. So the two corresponding force, one is the frictional force, that, and the other one is a normal contact force. So downward force matches with that normal contact force, and the W sin theta which is responsible for moving this object downward balances with the frictional force. And what is the Newton pair force for the weight? So that is the force of the box on the earth. So box is applying force on the earth, and that will be the Newton pair force for that weight. In question 7, a car is moving towards a stop sign at a speed of 25 meter per second. The driver applies the brake 20 meter before the sign and decelerate uniformly from rest before the sign. Which of the following give the magnitude of the deceleration? So initially, this is the initial speed. He applies the brake, so he will stop. So the final speed is 0. The distance moved, and it is deceleration. So 2as is equals to v square minus u square. So a is equals to v square minus u square divided by 2s. So v is the final speed. Initial speed is 25. So 25 square divided by the distance 2 into 20. So it will be minus 25 square divided by 40. So we just only need a magnitude. So we don't have to bother about the sign. So magnitude will be 25 square divided by 40 for deceleration. In question 8, structure question. The transmission of electricity over long distances requires a conducting cable that is suitable to hang a supporting towers called pylons. The vertical distance for the line to for support to the lowest point of a wire is called a sag. Due to high voltage involved, the cable must maintain a minimum distance from the ground. Like it should not move too much down because it's very high voltage. The temperature and the tension of the cable affect the sag. So if Like example, if the temperature increase, the sag will increase. If temperature decrease, the sag will also decrease. And the second factor which affect, that is the tension, like how much the cables are being stretched. That also, if tension is high in the cable, then it will have a smaller sag. Suggest one other factor that may have increased the sag of the cable. So the distance between the pylons, like if the pylons are closer to each other, then the sag will be more. Or we can also say weight of the cable. So these are the two factors which will affect the sag of this cable. A cable of mass m, capital M, is at an angle of theta to horizontal, so angle theta to horizontal. Explained why the tension in the cable decreases as the sag increase. So the question is why the tension in the cable is decreasing as the sag is increasing. So we have a tension, the force, tension for always to pull. So how we can relate the tension with the weight? So the component which is with an angle, if you want to compare with the weight, weight is acting downward for the cable, that balances with the tension. Angle will be same theta. This is T and this one is also T. So the component which is with an angle, this component will be T cos theta, and the component which is against the angle, that will be T sin theta. So T sin theta here and T sin theta. So this will be T sin theta. This will be T sin theta, and the weight will act downward. So what we can say? We can say 2T sin theta is equals to weight. As the weight is balanced, so the weight which is acting downward balances with the component of the tension, which is sin theta. So as the sag increases, the theta will also increase. So the theta will also increase. And what is the effect of theta? Because the relation here, that T is equals to W divided by 2 sin theta. So when the value of the theta increase, the value of sin theta will also increase. And when the value of denominator sin theta increase, the value of the numerator will decrease here. That's why the T will decrease. Is it clear? Discussion. The weight is not changing, only the angle with the horizontal is changing, which cause the decrease in the value of the theta. So, which cause increase in value of theta. As value of theta increases, the value of sin theta increase, which reduces the tension in this cable. In question 9, the graph shows how acceleration a of an object vary with time. Which of the following graph shows the velocity? So for velocity time graph, the slope represent acceleration. Here acceleration is increasing, so the slope should increase. For velocity time graph, here the slope is decreasing, here the slope is decreasing, here the slope is constant, and in this one the slope is increasing. When slope increase, it means the acceleration is also increasing. So D is the right answer for this. In question 10, which of the following statement is not correct for Newton's third law of pair forces? The forces act in opposite direction, that's true. The forces act on same body. That's wrong. They should act on two different bodies. The forces are of same type. That's true. They should have the same magnitude. So B is the right answer. That shows that it's not the right statement. In question 11, a ball is dropped and reaches the ground after 0.42 seconds. The ball bounces to the same height from which it is dropped. Draw on the graph below the velocity time graph for a motion of a ball, and you may assume that the time for collision between the ground and all frictional force negligible, and show your working. So how we first will work out in a ball is dropped and reaches the ground after 0.42. So first we'll find at what speed it hits the ground, and it will have an acceleration due to gravity. So v is equals to u plus at. Initial velocity is 0 as the object is dropped 9.8, and this will be 0.42. So we'll get the final speed in 0.42 second, which will come out as 4.12 meter per second. So that's the final speed. So v and on the axis, when we label this like 1, 2, 3, 4, and same thing -1, -2, -3, I'll zoom in so that I can easily plot this graph. If 10 boxes is equals to 1, so this looks 10 box, this 10, and this will be 10 box. So 1, 2, 3, 4, -1, -2, -3, -4. And then the max 0.42, so we can take like 0.1, 0.2, 3, 4, 5, 6, 7, 8, 9, 10 means 1. This will be 0.5, 0.4. So 0.1, 0.2, 0.3, 0.4, 6, 7, 8, 9, and then 1.1, 1.2, 1.3, 1.4, and 1.5. So when we plot the graph, because the final speed after 0.42 second, that is 4.18, so 4.18, two boxes approximately here, and two boxes from point 4, so it will be at this point. And because object will have a constant acceleration, falling object, so and the moment it hits the ground, so it hits the ground with 4.8, and then it bounces back and rises to the same height as they mentioned in the question. So if the speed before hitting the ground was 0.18, sorry, 4.18, then it bounce back will also be 4.18. But the only difference, it will be negative. So the same time interval, 0.42 second, it will be minus, and then it reaches, it will be 0 again, and 0.42 seconds plus the same 0.42 second it will take to return, so it will take 0.84 seconds. So at 0.84, this is 0.8, 0.82, 0.84. So at 0.84 it will return back to the same height, and it will have initial velocity 0, and we can join these 2 points as well. So this will be the graph for showing the motion of this object. The parallel lines should be there. These two lines should have the same slope. Why? Because they will have the same acceleration and deceleration. In question 12, a skydiver jumps out of a plane and fell for 50 seconds before opening his parachute. The graph shows how a skydiver velocity vary with the time over 50 seconds. Explain the shape of the graph. So how we explain the shape of the graph for this skydiver? Initially, you can clearly see he's having initial acceleration is there, that will be due to gravity. So initially, acceleration is due to gravity. No frictional force or air resistance, or it will have a maximum acceleration at the beginning. But then what happens as the velocity increases, because it is accelerating, so velocity increase, result in increase in air resistance or drag. The resultant force decrease because the drag is opposing the motion, so resultant force decrease, which reduce the acceleration. Slope of graph will decrease, and eventually when drag force or air resistance equal to weight, no resulting force, it moves with constant speed and zero acceleration. Sketch on the graph motion of skydiver as he open his parachute. So when he open his parachute, he will decelerate and eventually he will reach a terminal velocity, but this will be lower terminal velocity, so that will be safe to land on the ground. Explain the effect of mass of skydiver on the terminal velocity before he open his parachute. So if weight is more, the air resistance, the greater air resistance is needed, so greater drag force is needed to balance with the weight, so it will have a higher terminal velocity. So if mass of a skydiver increase, the weight of the skydiver, then it require greater air resistance or drag force to balance the weight, which results in higher terminal velocity. Explain how skydiver would decrease the terminal velocity as he falls. So how a skydiver decreases the terminal velocity. So as a skydiver opens the parachute, or what he can do, he can increase the drag force, because the drag force is there, which is balances with the weight. So he can increase the drag force by increasing the surface area, which will lower the terminal velocity. The skydiver jumps as being filmed by another skydiver. Both divers jump out from a plane. During the period filming, only the skydiver who has been recording open his parachute When viewing the recording after a jump, it appeared that Skydiver being filmed move upward as he opens his parachute. Explain this apparent motion, movement. So why this apparent movement is there? The moment he opens the parachute, then air resistance is more than the weight. When air resistance is more than the weight, so resultant force is upward. So the answer for this one, the skydiver with open parachute slow down, and the skydiver who's filming remain at a constant speed or move with constant speed, which shows that the film shows relative velocity between the two skydivers. So basically what happened, as I mentioned, the skydiver jumps was being filmed by another one, but both jumps together out of the plane. During the period of the filming, only the skydiver who was recording opened his parachute. So when viewing from recording after jump, it appeared as though the skydiver being filmed moved upward as he opened his parachute. So basically what happened, the one who opens the parachute will slow down, and the one who's accelerating will continue to accelerate. So when he's filming, it appears that this skydiver is moving upward. So it sees a relative velocity. So this one was AS level physics motion graph and fourth assignment. In the next session, we'll discuss more questions from this assignment.